Hello and welcome back to Red Hat OpenShift Data Services Office Hours. I'm your host, Frank Lavinia, the global go-to-market lead for data services here at Red Hat. And with me, I have two fantastic guests that we're going to talk about TRino, S3 Select, and Ceph. So stay tuned. All right, welcome, Gal and Daniel. So tell me, let's talk about data and data storage.
Yeah, hi, Frank. So we wanted to cover today a little bit about IBM, storage Ceph, just Ceph in general, not since we moved to IBM. But in the end, we are doing a lot of work with analytical tools, improving object storage, especially speaking about object storage and all of the movement that we have from the data side to actually data lakes, data lake houses, to really consume storage and objects that we have lying around, like unstructured, structured files that we have in our S3 object that can be interesting to analyze for data tools. So we really wanted to go through a little bit one of these tools, that is TRino, Presto, cover it at a high level, and also show how it integrates with Ceph, with Radar's Gateway, that is the object storage side of things from Ceph. In the recent times, we have been doing quite a lot of work regarding from the RGW team, the Radar's Gateway team that Gal is part of. We have been doing a lot of work with analytical tools and improvement there. One of them is S3 Select that we're going to cover today, that is really pushing down the SQL queries into RDW. But there are other things going on, like, for example, having cache tiers closer to the compute. So you could also improve those SQL responses by having a cache, also intelligent caching, that we call D3N, that is coming out on the next release of Ceph as GA, in 6.1. And then we have like an advanced cache that is going to be called, it's called D4N, that is taking it to the next level, because it's like intelligent caching, and it's really trying to improve the general performance of the analytical tool experience by reducing, accelerating queries, and getting things to go faster.
No, I think that's important because, as a data scientist, I can speak for a lot of other data scientists that we don't think about the storage, right? Storage is just one of those things that just magically appears. It's all magic, right? It's kind of like, when you go and you flip your light switch on, you don't think about all the logistics and all the engineering that goes into making sure the lights work, or, you turn on your phone, right? Like, it just works. And I think that storage is really, previously on this YouTube channel, I talked about the notion of rock stars and roadies, right? Like, data scientists have been used to being, the AI is really the rock star now, right? Like, large language model this, large language model that. But underlying all that, there's a lot of material, right? A lot of the roadies, right? So people may show up for, the large language model magic, or the AI magic, but underneath it all, there's just mass quantities of data. Mass quantities of data have to live somewhere, and they're in storage. So I think it's important we understand kind of the full stack here, and what Red Hat and IBM's response or answer to this is, because storage is a fundamental aspect to not just data science, but just business in general, right? If you write a web application, right, that data has to go somewhere. People don't want to enter their shipping address every time they go and buy something online, right? Or, kind of do all that, right? Obviously, I guess some privacy people would love to do that, but data has to be stored somewhere. So tell me, so Ceph, what's the foundation here? The foundation is Ceph, and that's storage over OpenShift. Is that basically what it is?
Yeah, so here we have like two approaches in which you can actually consume Ceph, or in this case, Radar's Gateway or the S3 object storage. That is really what we are speaking about, thinking about data lakes a little bit in the old school, or maybe data lake houses, that where TRino or Presto also comes into play, where we have this SQL engines, that we want to really reduce the times that it takes to just query and analyze data. So Ceph, really, you can consume it standalone, we could say. So you could have like a standalone deployment with your bare metal nodes, and you can actually deploy that in huge sizes, because the scale out capabilities that it has are really great. No, you could grow into the petabytes, into the exabytes, so it can go really huge, like a data lake. But you could also consume Ceph, as you mentioned, inside OpenShift. No, that this is what we call OpenShift Data Foundation, or Fusion Data Foundation in the IBM side of things. So that's also possible. Raiders Gateway, so the object storage interface is also available there. The only thing is that normally inside OpenShift, as you can imagine, you will see like lower scale deployments. Now it can also scale because the architecture that is there is Ceph now in the end, and Ceph is really built to scale out. But you will normally, just by the nature of OpenShift clusters, no, they will be a little bit lower inside. So you can actually do both. No, you can consume your S3 storage from OpenShift to an external Ceph cluster, a huge external Ceph cluster, or you can actually run as pods with operators your Ceph cluster inside OpenShift. No, so that's also a choice that you can make.
Okay, interesting. So there's a lot here that I myself am not necessarily familiar with, and I think I don't want to speak for the audience, but I think it's always good for data scientists to get off from the top of the mountain and kind of understand how things actually work under the covers, because I think that can help data scientists be more efficient and more effective in terms of making sure their models can train faster, because ultimately it's about the pipeline, right? And a big part of that pipeline is the data that's actually stored. So I understand you have a demo.
Also, the thing is that we're going to start with explaining what is all about the push down paradigm. What is S3 select? It's this buzzword need to be explained first. We can also demo it. By the way, it's here. But as you said, as a data scientist that live up there, we're going to explain now. I'm going to explain now how does it look down there from the middle tier, I think, from the Rados Gateway point of view. But Rados Gateway point of view, which is another buzzword, by the way, you never heard about that, and you don't want to remember about that, but it's there. And we're going to explain why using this latest feature of SS Select integrated with TRino, which is a more common analytical tool, is really a great combination. And that's actually my main mission today. And
excellent.
Okay.
No, excellent. Let's see it. I'm excited because this is a side of our products that I've not really spent a lot of time in. So.
Okay. So I will present now.
Yeah, please go ahead.
Okay.
I will just mention while Gal is sharing the screen that also we can, it's not exactly that, but it's true that if you hear Trino, if you hear Presto, or Trino SQL, so they're interchangeable more or less, no? Because they were forks, no, from the actual initial project that started at Facebook. But just in case we speak about Trino, Presto, you could more or less think of them as interchangeable. It's true that each of them have developed separate branches, no, but more or less the architecture and the schema is the same.
Okay. You can see that? Okay. So 1 second, let me organize my screen here. Okay.
And I can cut this part out, and I can edit this part out.
Okay. So yeah. So in July 20, first of all, my name is Gal Salamon. I'm a member of a Ceph team. I'm in the Ceph team for the last recent 4 years. My main focus is S3 Select, this analytical brand, how to make the Ceph storage, how to make the storage, okay, much more attractive for analytical operation. And actually, this presentation is about that, to convince you that it's much better now. Okay, so in July 2020, SSTech was introduced first to Ceph Upstream. By the way, it was announced by AWS in 2018, about 2 years before that. S3 Select is another S3 request. It enables the client to push down an SQL statement into Ceph storage and actually run the SQL statement inside the storage itself. It's not an easy thing to do. I will try to explain why it's not easy and why it's so important to do that. S3 Select it's a new S3 capability. It's designed to pull out only the subset of the data that you need, and this can dramatically improve your performance. It reduces also the cost of the application that needs to access the data in S3. And it should be noted that the S3 request implementation inherit. This is a bit needs some explanation. There is a general thing like, give me the object, give me the file that I need. And what I'm trying to say is that this new capability of running SQL statement inside the storage, we didn't change the Ceph, we didn't change Rados gateway. We rely on something that is already there. I will try to explain some more in later slides. I can say that S3 select is kind of get me my object on steroids. It's the SQL expression and its processing is the main difference, and that we'll discuss later. Okay, why do we need that? What is it? Why does it so good for? For what purpose is it good for? Now, it's about push-down paradigm. Okay, the push-down paradigm, it's an old notion. Actually, if you know Oracle, you have the store procedure for one example. It's very old paradigm. You have it everywhere. It's something that these days been discussed and done also in so many features in hard disk and stuff like that. In this case, the push paradigm is about actually moving the operation close to the data, which is really contrary to what we commonly do. We're usually moving the data to the place of the operation. We bring the data to the place of the operation. So push down does not, and you need to understand that push down does not consume memory while caching. If we are using caching for storage, does consume memory. And in big data ecosystem, it's really make a difference. Think about all these objects of terabytes, and you need to cache it. It's really a problem. So again, upon using a cache paradigm, the flow is about what data to keep in cache and what data to invalidate. Okay, so and upon pushing down, the flow is about what operation should push down and how to use the return result. So let's take one example. Let's say you want to execute the following query. Select sum of column X from some object where column A is bigger than column C. So usually what you do is you need to fetch the entire object to the client side, okay? And only then to execute the operation with some kind of analytical application. With pushdown, as to select in this use case, the entire operation is actually executed on the server side, and only the result, which is a restricted subset of the data, only that is returned to the client side. And this is a crucial sometimes, could be very crucial. An SQL query that needs to operate on CSV or JSON object that contains many columns and rows, but needs only a very small portion of it, a few columns or maybe a small percentage of the rows, will return only a small amount of data, meaning less operations of serialization and deserialization. And also it should be noted that pushing down operation close to data, it's not an easy thing to do. The storage is usually very fragmented. These objects are break to many pieces. It's all over there on the cluster, and it's very difficult to execute a single query on many random pieces. And some of these pieces could be a binary object. So to your question, it's quite complicated to push down SQL statement and run that on some kind of object. What SSLEC is capable of? SSLEC does not turn your storage into database. Okay, your storage remains a storage, but it does improve greatly the efficiency of the SQL processing. It should note also that SQL dialect that we provided by the SSLEC is for read only. It's for the select statement, And there is no notion of schema or table. The object should be read, should enable tabular operation. SSLX system is embedded into the get object module. It's embedded into all the modules of handling the storage. So it makes it very efficient for the push down operation. So upon SQL query being pushed down, the object is fetched, and each fragment of the object is processed by the SSLX module. And since the SSLX is embedded into the S3 system, there are no redundant copies of bytes. The object is processed immediately, and results sent back to the client. Moreover, the SSLX system is capable of processing different types of objects like CSV, JSON, and also Parquet. And the same engine is processing all of these object types. Now, for the question that maybe was asked is why using SQL? Okay, so SQL serves as a querying language for machine learning, since it's a standard language for accessing and manipulating data. And also should be noted that SQL it's a domain-specific language, more than 40 years, and was designed initially for manipulating data. So in machine learning workflow, data is the primary source, and its accuracy and relevance are critical for the successful modeling and pattern detection. So it is essential to ensure that the data is properly formatted for use by machine learning algorithm. And furthermore, in later slides, we're going to discuss the TRino tool that can perform the push down operation on of SQL statement, enabling that. And this is really interesting stuff, because the TRino is able to take a huge SQL statement, back them into a subquery, and push them for optimization into the storage. And this is why we think that we know, not just thinking, that the integration of TRino as an analytical tool for data scientists and Ceph, which support SSLX, it's a great combination for a much better performance. So also, given the ability to read and process common data sources such as CSV and JSON and Parquet, SSLX is a really viable tool for machine learning purposes.
So for my fellow data scientists out there, not everything comes ready-made into a pandas data frame.
Exactly. Yeah, and in this slide you can see actually it's really a simple one. The amount of data that's actually passing by from the storage to the client side. So why SSLX is useful for our storage, for S3 storage, is we know that S3 storage is reliable, efficient, and relatively cheap. A typical Ceph user may aggregate along the years tons of objects. These objects contain huge amount of data, structured and unstructured. This massive amount of data is sitting there in a cold state, and that data could be very precious to you. But to know that is precious to you, you need to actually extract this data from the storage, and this is really expensive. Think about, you have terabytes of CSV and JSON, and you need to know what's going on there. So this kind of operation consumes a lot of network and also CPU, because all of this serialization and deserialization operation when you are extracting information from the storage. But while using SSLX on this kind of cold data, it makes the SSLX very cost-effective for analytical operation. So you can say that our goal is to turn the Ceph object storage more attractive for analytical operation, not just for storing data. Okay, some points of software design. I really make it a quick one. The engine itself, from C++ perspective, is a header-only code. There are no libraries. Also, one exception is the Apache Aero Parquet. You need that for the Parquet reader. It's a single-threaded function. It reuses memory for its operation. There's no intensive allocation or deallocation. This is very important for intensive data reading, this kind of property. The memory that is consumed by the engine is enough for the raw being processed, and for that reason, and that is really important, the engine is able to process any size of object. There's no kind of preloading or something like that, because the engine is built in a way that is actually allocate enough memory to consume the next step, and that's it. And reuse again and again the same amount of memory. It's also, by the way, a standard application, not just in Ceph. You can actually run it. You're going to see that. The same S3 select engine can be used from the command line and shell command, and it can process a different type of data like CSV, JSON, Parquet. And now I'm going to explain a bit about the different types of the input data source. We actually currently support 3 types: the CSV, which is quite common, and the JSON is also quite common, and Parquet, which is considered a very efficient binary format. And they're quite different in the way the storage internals are actually process that. So as said, CSV is the most simple format. It's not supporting data types. It has a trivial schema of support. Almost every log file can become a CSV object. JSON is more sophisticated format. It supports data types and also a schema. So need to understand that upon processing a query, both format, the CSV and JSON, you have to read the whole object. So in the case you have a big table of 1 terabyte, okay, and it's a CSV object or JSON object, you have to read all of it, okay? Even if you need only a small portion of it, but in order to know that, you have to scan all the whole object. That's the set story. That's why to push it down, it's much better. Parquet, on the other hand, is very advanced object. It contains enough metadata that enables the user, to access only the data that you need for the query processing. And that it means by using Parquet object, it's not just saving network bandwidth, which is really important, but it also saves a lot of IOPS on the server side. Okay, so let's talk about the flow itself. You can see here the CSV. In the case of CSV, the Rados gateway fetches a chunk after chunk. We need to understand that objects that are saved into storage are not saved as a contiguous big chunk of memory or on the storage. They are actually break into many pieces. In our case, usually there are 4 meg pieces, so it's hundreds and thousands of little chunks. And what Rados gateway is doing is actually pushing this chunk to the S3 select engine, and the S3 select engine knows how to process that. This chunk actually breaks. If you think about a CSV, the regular CSV that we know, it actually breaks rows in the middle. It actually breaks fields in the middle. But the engines know, the CSV reader and with the engine knows how to stitch it together without reloading. And this is really a crucial feature for this kind of processing. Okay, so if we're asking about what happened down there, this is what is happened down there. Yeah, the object is completely a break to many pieces, totally fragmented as random pieces, and the engine know how to gather all these pieces and to run a SQL query on it. Okay. The next thing, okay, and here on the contrary, let's discuss the Parquet issue, the Parquet use case. So Parquet is a binary file. It's what we call a columnar object. this type of object contains a lot of metadata. It enables the reader to skip non-necessary information. At first, the engine is validating that it's really a Parquet object. But in the next step, what it does is actually fetch only the columns that actually participate in the query itself. So if we take the example of that we used earlier, select A where B bigger than C, it will only fetch the A, the B, and C, and actually it will fetch the B and C, which belong to the predicate, and only if it's returned true for the B is bigger than C, only then it will fetch A. And now, since it's a Parquet object, it only fetch only the only to fetch this data and without scanning anything else. And this is really a huge. It's quite efficient compared to the other two types of JSON and CSV. So just to a bit explain about that. So the main difference between the Parquet reader and the CSV reader that upon CSV flow, the Radius gateway, this layer that fetch chunk after chunk and process at each of that separately. You can say that the Radius gateway, the storage, this storage unit control the start and the end of the process. In the case of Parquet, the engine, the engine itself is issuing a read range request. So it means that the SSelect engine is SSelect engine control the start and the end of the process. From that data scientist point of view, it doesn't too much of a difference. Okay. As for the JSON, as you can see here, it's a bit weird slide. I'm trying to explain why the JSON reader is unique compared to other readers. So upon query a JSON document, the SSelect engine is focusing only on specific parts of this nested and complex JSON data, and not the whole JSON, documents. It means that only specific parts of the JSON documents are loaded into the SQL engine for processing. And a short example, you can see in this slide that the statement here is focusing, it's processing on a specific part of the documents according to the from close construct. You can see that if you look on the from close, it's actually a path, and this path actually tell the JSON reader where to look, where to start to look for the next row and when the row is ended. So you can say that the from clause is actually define the boundaries where to get the projection and the predicate columns. Okay. So in this next slide, you can see that I changed a bit the from clause. So if you look at the boundaries of the row, it also changed a bit. Okay, it changed because now upon the JSON reader is reading the whole document, it's actually reading a bit differently. It's only loading only some parts of the JSON documents. Why I decided all of this? Because it must note that from the storage point of view, it's really a big mess. If you think about a big JSON or many JSON files, in the storage are break to many pieces. So the only one that can actually knows when the row is started and ended is the JSON reader itself. So you can say that in contrary to the other readers, the JSON reader is the one that actually is leading the processing. And this is quite different from the other reader, which is the CSV and Parquet. This thing that which I'm noting now is really for the people which are a bit more technical for the storage layer. it's a big difference. It's a big difference to read a JSON document and then make SQL processing compared to Parquet and compared to CSV. Let's move on to the next one. Okay. As mentioned before, it's quite easy to run SSLect from the command line. Actually, you can run it on a shell command. It can work on a standard input or on files which reside on your local file system. You just need to review the GitHub repo. Let's look at a few examples here. Okay. In the first example, the SQL statement is actually processing the standard output of a PS command. Okay, it's just for presenting the power of the SQL statement and engine. And this time it processes the input as a CSV type. So now, please know that the SQL statement uses the column names, uses actually the columns that you see here in the statement itself. It does select PID, select command from STD input where the parent PID is equal to 1. And how does it know about these column names? It actually extracts that from the first line of the PS command. And by I'm indicating that with the CSV header info, this is the way the CSV know about the schema. You just state that the first line is actually the column name, and that's it. And again, this is from the command line. A second example, you can see that I'm using already existing container. This input data is piped into the container itself. Okay. The container consists all the necessary, by the way, this container specifically contains all the necessary packages, also as a Apache Arrow and for Parquet reader. You can also, you have the build utilities, it's enabled the user to review code, change the code, and actually rebuild that if somebody wants to do that. And the third example, you can see it uses the same container. In this case, it mounts the host directory to the container directory. It enables the user to run SSLect on any file without installing or building SSLect, actually. Okay, challenges ahead of us. And this is maybe the main stuff that we're actually working on that on the recent weeks and months even. It's the integration with TRino and maybe later with Spark also. We also are, of course, considering Espresso as well. So SQL analytic application such as Spark and Presto or TRino may use the object storage as their backend storage. Okay, but as said, it's very inefficient to use this kind of storage sometimes, and that is because it needs to retrieve the whole object participate in the query itself. So upon using SSLect request instead of get object, this will improve the query performance dramatically. So you understand that the SSLect is actually kind of an optimizer for this kind of for this high-level application. It means that the TRino, the Spark, and the PrestoDB, actually their engine analyze the big query and know how to make it much more optimized by breaking it into subquery and push that to the server side and reduce significantly the amount of bandwidth, network bandwidth that you need for processing this query. By the way, this type of optimizer already exists in AWS EMR, and almost the end of the presentation, I really want to show you. This is an article that was published only in the last November by AWS and TRino and Starburst, and it's a joint effort. They actually improve and upgrade the TRino software and also contribute that to the open source. And we're currently using that open source this recent months for our integration of Ceph and TRino. They ran TPCDS benchmark in scale of 3 terabytes on that integration of TRino and AWS software. And as you can see, I highlight some parts of that. The results are really, really impressive. The best query was about 9 times. The reduced overall network bandwidth, I think about 21 times. And it's really, it's a big thing. And they're making a lot of, and I can see by looking into the repo, TRino repo, they are doing a lot of job there of the integration between AWS and TRino. Okay. This slide, we are currently doing this benchmark that was run by AWS and TRino. We are actually going to do that ourselves to show that also that the combination of Ceph and TRino and STSelect, of course, it's a great combination. And from this really small table that we only run a few queries, you can see that the amount of data that is going back to the client side is reduced significantly by this query, of course, from 10 gigabytes to a few megabytes. And a number of rows, again, it's instead of returning back 65 million rows, you're returning back only 200 in this case. And they also reduce the amount of seconds that you need for processing this data. And I think we're done. Yeah, we're done. And that's it.
Yeah. What I wanted to ask you there, Gal, is also that this example that you have here is really not a benchmark. No, it's just a test. That don't take the data there as something that is like done through a benchmark. It's just to show the enhancements and to just make clear those advantages on what you can save from the network, and also how you reduce the query times by doing those push down jobs from the storage. So it's just to take that into account. And I understand that you're actually working on the true benchmarking and getting some results there also.
Yeah, the results are really quite on the first stage, yes, but we are using TPCDS. What we're actually doing now, we are uploading TPCDS data and running these queries, and we can see that sometimes it's about 5 times or 10 times. It depends. It really depends on the query. If you do like a select star where everything, so you bring up the whole object, there's no much of you don't get too much efficiency. But if you are you're going to select only a small portion, a few percentage, less than, and that's the thing that happens many times. When you data scientist does its work, you're going to really reduce really a lot of network bandwidth and improve the overall performance of the cluster. Once we have these numbers, we will be happy to, of course, to publish that.
Yeah, because from what I understand now, from what you just said, there's also that it depends on the size of the data set, but also it depends on how specific you are with the SQL query that you're running. If you really filter down that SQL query, you make it really big, and you're targeting a small portion of data, the improvements are going to be huge compared to maybe, as you said, a select asterisk where you're just querying everything. You have to bring everything. Those results are going to be huge, and you're going to bring everything back to the client in any case, so you wouldn't see such a big improvement. So it actually depends.
Yeah, it depends. We can take a really small example. Let's say a table, and say bring me all the rows where column A is equal 5. Let's say it bring only 1%. Now the second query says, bring me all the rows that where A is not equal 5. So we'll bring all the rest, which is quite big. So that's why they're saying also in AWS, you need to analyze your query and find out if that's what you need. From the majority of use cases, it will really improve your efficiency in a significant matter. That's for sure.
Because as long as your queries are written in a way that can be efficient.
Yeah, your query and data profile. Yeah, you need to know about your data profile. And there's no. This is the reason that they actually AWS developed this feature, because they understand that so much network is consumed to bring back so much data. Once the main thing is that with huge objects, when you have a terabyte of objects and you need only one column, maybe you have 4 columns and you need only 1% of it. Before the S3 select, you need to bring the all objects back to the client side, which is a lot of things to get back, a lot of network benefit for that. And now after S3 select, when you push down the query, it's a different thing. Now there is of course there's a trade-off. You actually you're asking the storage to allocate more CPU for this operation, but this trade-off is become we know that it's much more efficient for us, because we also by the way, we also reduce the amount of serialization and deserialization. When you are getting a terabyte of data from storage, from one side, the storage side, to the client side, over the network, you need to serialize the data and deserialize the data. And this is also a lot of CPU. But when you only bring back only a few kilobytes or few megabytes of data, much less of serialization and deserialization operation.
So it's not just about the amount of data that's going through the pipe, it's the amount of work to stuff it into the pipe and send it down. So in this example here, a 9.5 gigs of data is going to require a lot of work, whereas 1.6 meg is probably not a big deal.
No, exactly.
So it's almost like it has cascading efficiencies.
Exactly.
Interesting.
And go ahead.
Okay, the thing that we need to maybe to present somehow, the Trino is a very sophisticated engine, and I'll try to explain why we are so eager to integrate that with Trino. SSX by itself is very, it's very limited SQL dialect. Okay, you have some, let's say, some construct in there, but it's quite limited. It doesn't have join, or it doesn't have group, or stuff like that. But and it also the SSX, upon its operation, it only operates on a single object. It doesn't operate on many objects, and this is really a big difference. While Trino, which is a much more advanced engine, is actually it's a full SQL engine. Upon defining a table with a Trino create table statement, you actually can point on a bucket of objects. Okay, so your operation going to operate on many objects. That's one thing. But more than that, the Trino engine know how to split and cut the objects to many pieces and run many queries in parallel. And this kind of thing is really a huge thing, because it accelerates much. It's not that when you are doing S3 select query, you actually sending a single request, and you asking the server to push down a single SQL query and to do a single operation. While you are doing that from the Trino client, it's totally different. It actually what it does, it breaks the object into many slices of the object. Let's say if it's a 10 gigabytes of object, you actually slice it into 1,000 of tiny objects, okay, non-overlapped objects, and per each you send an SSelect request. So you get a magnitude of efficiency on this case, and you can see that immediately. I mean, this is without question, what any question, is much more efficient. You actually uses the storage much more in a great scale. You actually need to stop it a bit, not to do it too much, maybe sometimes.
That's
Yeah, no.
interesting. That's interesting. Go ahead, Daniel. I'm sorry, I cut you off.
Yeah, no, I was just going to mention that also fits very well into a little bit of the lake house discussion in the sense that we're trying to move a little bit from the data lakes where maybe some kind of like Hive SQL query will take loads of time to give you a response and answer, and now moving into kind of the data lake house where we want to be similar, we could say, or have similar features as a warehouse where a SQL statement wouldn't take ages to actually come back. No, and all of these things that we're seeing here, Trino, and how it can work in parallel with the help of, for example, S3 Select and certain cache layers, can really take us to that place that we want to be in, with the data lake houses.
So you have several points of leverage of efficiency. You you reduce the amount of network using SSelect. You have the operation of serialization and deserialization. You reduce that, and you're using parallelism. And this is really a great thing. You're getting here much better efficiency upon running a SQL query with this kind of combination. This is really a winning combination. This Trino with SSelect, it could be also Presto with SSelect, and hopefully also Spark with SSelect, because the SSelect is kind of become a common S3 request, which other engines want to support that. That's wishful think also that which will this feature will also be supported by the other SQL engine later in the future.
Interesting. It's a fascinating field, because I think that there's, as the cutting edge of AI kind of moves further and further into requiring more and more data sets, little bits of optimization. And this, not saying this is little, but bits of optimization, I think are really going to be competitive edges for organizations in the future. I mean, not just cost, but also time.
It's cost and time. It's also cost. Yeah. It's a cost because bandwidth, you pay for bandwidth.
Right, exactly. Well, also, if you're dealing with kind of, again, I don't know how much the edge side of things really touches this, but if you're dealing with kind of constricted bandwidth for one reason or the other, this is a big deal.
Yeah, could be. Yeah.
Interesting. All right, so where can folks find out more about this?
There is the repo. I mean, there is SSelect repo, of course, that we will be happy to see people actually contribute or making comments or ask questions or want to, I don't know, any idea they have. This is really, that will be great. We think about putting more data types. I mean, currently we have CSV, JSON, and Parquet, maybe ORC, maybe others. And we're thinking about more connectors like Iceberg. Iceberg is very interesting because Iceberg is talking about table management. It's something that you need a separate presentation for that. And this is something for the maybe 6 months from now. We're going to handle that also. But if you go into the net, you can see that others already using the Iceberg table management, which is really show great efficiency when it comes to how to manage very big tables.
Interesting.
Yeah.
Cool. All right. Well, thank you, and see you next time on Data Services Office Hours.
Thank you.
Bye-bye.